Okay, everybody. So 8.2 is about the reciprocal function family. Now, the reciprocal function family is going to move, just like we're used to. It's going to move up, it's going to move down, it'll move left, and it'll move right. It will have those concepts of asymptotes that we've talked about before. They'll approach lines and not touch them. But let's go ahead and take a look at what they're going to look like. So we're going to have y equaling some number over our independent of x. So it's going to be like a y equals kx, which is introduced to you in the previous lesson. X cannot be 0 because you can't divide by 0. We're going to call this, and it's the parent function, y equals k over x. That's the reciprocal function. The most basic form is when k is equal to 1. So if you have y equals 1 over x, that is the most basic reciprocal function that we can have. Now, in general, just like we had before, they're all going to have their own specific shapes. So if you remember, we did linear or straight lines. We did quadratics or parabolas. We did square roots and cube roots and all kinds of different types of graphs so far. So your new one now is this reciprocal function. So this is the basic graph. Please notice that they have an asymptote naturally of the x-axis. Look how they approach but never touch, and the y-axis. Okay, but now those are the most basic asymptotes for the most basic type of reciprocal family functions. And as described, if a becomes bigger, it's going to be vertically stretched, and if a becomes smaller, it's going to be vertically shrunk or compressed. All right, so we can have a vertical stretch or a vertical compression. We can also translate it left, right, up, and down the same way that we have all other functions thus far. So what I did is I went to Desmos and I put a whole bunch of graphs down this side and a whole bunch of equations that match those graphs on the left. So let's take a look at the parent function of y equals 1 over x. Now the vertical asymptote is, well, let's look at the number being added or subtracted in the back. There is no number being added or subtracted into the back other than 0. So your vertical asymptote will be on the y-axis at x equals 0. So it'll have a vertical line that it never touches. Excuse me. The horizontal asymptote, well, let's take a look at what's being added or subtracted to x down here. See how it's like plus 0 essentially down there? That means your horizontal asymptote is going to be y equals 0. It'll be a horizontal line that it approaches but never touches. Now, your domain is x equals any number in the entire world. You could put anything in there for x that your little heart desires. However, we do have a rule. You cannot, so I'll write except x equals 0 because you can't divide by 0. So your domain is all real numbers except x cannot be 0. Your range is going to also be y is all real numbers. However, because we have that asymptote up there, we also cannot have y equals 0. So there's no value of x that will ever give you 0 for y. Now, when this happens, what I want you to do for your xy chart is put your, like whatever's down here with x, just like you would do the opposite of it as your middle point. So if it says plus 5, put a minus 5 in there. Well, this is a 0, so we'll put a 0 in the middle. I'll surround it. Maybe I'll count by ones on this problem. Maybe I'll do like -1, -2, I don't know, and just -5 to see how it behaves. And then I'll surround it this way as well. So I can use my calculator. Let's see if I have one pulled up here. And I can type them in by hand if I want to. You might know a lot of them by heart already. But I'm going to type in, remember how it was 1 over x? I'm going to type in 1 divided by -5. So if I plug in -5, I will get out -0.2. I'm going to zoom in right here so I don't have to scrunch my handwriting. Now remember, I'm plugging them into this original equation. So I'll do 1 divided by -2. And I get -0.5. And if I plug in 1 divided by -1, remember I'm putting the values in for x, I end up with -1. Now if I try to do 1 divided by 0, I'll have a no real solution. So this is because this is where my asymptote is. So I'll just write no answer. Now if I do 1 divided by 1, I get 1. If I do 1 divided by 2, I get 0.5. If I do 1 divided by 5, I get 0.5. 1 divided by 5, I get 0.2. Excuse me, I just misspoke. So if you look at this graph that I had Desmos do for us, sure enough, if I try to match the colors here, you can see how -1 and -1 is a point. You can see how -5 and 0.2 is a point. You can see how negative 2.5 is a point. Let's see, 1, 2.5, there it is. Now, if you're wondering how does this side behave, you could always plug in numbers that are smaller than -1, like absolute value-wise. Like if you really want, I wonder how it behaves at negative 0.5 for x. So if I do 1 divided by negative 0.5, I get negative 2. And sure enough, you can see at negative 0.5, here I am, boom, boom, down here at negative 2. So you can see this shape that is taking, and they all take these like curved-like shapes that approach the axes. And you can see the same thing, all of these numbers here. Oop, lost my point too. All of those are being shown up here as well. And so you can see the parent function looks, well, like this. Kind of a silly looking graph. It approaches the axes but never touches them. They go on forever approaching those asymptotes. But now let's go ahead and move. Let's transform it. So what you notice here is I'm going to give it a vertical stretch of 18. So the transformation up top, the 1 became an 18, so I'm going to write a vertical stretch of 18. Now the vertical asymptote is like, hey, what up and down line does it approach but never touch? It's the same thing. It's not moved left or right, so there's still a 0 down here, so the vertical asymptote is 0. The horizontal asymptote is 0, because I didn't add or subtract anything to the back. Your domain is the exact same, and your range is the exact same because we haven't moved it up, down, left, or right. We just stretched and compressed it. So I'm going to cheat and throw those over here. Now, the XY chart, maybe again, you want to see how it behaves in this particular graph. So we're going to put our vertical asymptote, that middle value of 0 in here. And sure, we can pick -1 and -2. And maybe we even want to pick negative 0.5 to see how it behaves. And maybe +1 and +2, and maybe positive 0.5 and see how it behaves. Just remember, our new equation is 18 divided by x. So I'm going to go to my calculator and do 18 divided by, I'll start with the -0.5. I get -36. Whoa, that's super large. 18 divided by -2. -9. 18 divided by -1 will be -18. Divided by 0, that's where the asymptote is, so I'll have no solution. Again, I'm typing it into, I'm taking 18 and dividing by my x's, and my middle x came from my vertical asymptote. So if I plug in 1, I get 18. Plugging in 2 gives me 9. And plugging in positive 0.5, if you're not sure, it's going to turn into positive 36. So if you look at this graph, I do have the parent function. The original one's still in red. But what I want you to see that this has truly been vertically stretched by a factor of 18. So instead of +1 being at +1, +1 is now at 18. So if we graphed this, here's +1. Positive 18 would be way up here, which is exactly where it's going to. And if you look at negative, let's take a look at -2 and -9. Let's see that point. I'll change it to blue since this one's graphed in blue. So I'm going to look at this point, -2 and -9. So -2, 1, 2, and you can see sure enough, this must be counting by 2, 4, 6. This is counting by 2s. So if I'm looking for -2, here's, let's see, here's -2. So I guess I kind of misspoke on that one. And -9 would be 2, 4, 6, 8, 9. There it is. So you can see it still has the same asymptotes. It's still approaching the x and the y axis from the positive and the negative directions. However, the points are just taller. So we do still have this vertical stretch happening. Now, let's go ahead and transform it. This time we're talking about green. We got a lot of transformations. So that's not the right green at all. There we go. That'll be a little better. The negative on that is going to reflect it. So you'll see the different shape there. This +3, you're going to notice that that whole graph is going to shift to the left, just like it would before, 3. But we still have a big +0, so it's not up or down. All right, so your vertical asymptote. Your vertical asymptote is if we change the back number. I'm thinking this through, right? So let's see. Oh, no, I said that wrong. Your vertical asymptote is if we change, that's right, the number with x. Please forgive me. So instead of being x equals 0, where it typically would be, it's going to be at x equaling -3. Now, if you're not sure why it's x equaling -3, please watch the math. we know that our denominator, x plus 3, is not allowed to be 0. So if we subtract 3, we can see that our asymptote is going to be at x equals negative 3. Let's take a moment and show that on this graph, okay? So you see the green graph. If I were to graph a negative 3, it would be like right here. So you can see how the asymptote move. And I'll make that a broken line. Asymptotes are typically graphed with a broken line. So let's go ahead and select that. Here's negative 3. So you can see that this asymptote truly is at negative 3 when I draw it here. So there's your x equals negative 3. You can see it's approaching it, but it's not touching it. Now your vertical asymptote, your horizontal asymptote is still going to be at y equals 0. What I'd like you to please note is that it's still approaching the x-axis, the green line, and that is because I didn't move it up or down. Your domain is going to be a little bit different. Again, x can be all real numbers, however, except I can't make my denominator 0, so just think about your asymptote is going to be whatever your asymptote is, because you can't plug negative 3 in. Your range is going to be all real numbers, except, well, what is my asymptote and then y? For y, y is not allowed to be 0, because there's no value of x you can plug in there to get 0. So whatever the back number is helps you determine what your range is. It also helps you with your horizontal asymptote. All right, now, the question becomes, well, okay, I see that you moved it to the left, so how do I change my XY chart? Please make that middle number negative 3 now. Remember how it was 0 in the previous problems? You don't want it to be 0 anymore. You want it to be negative 3 because it's kind of like, do you guys remember when we did parabolas and like this was a parabola? Remember your middle x would have been a negative 3? It's the same thing here. That happened with all of the functions we looked at. Even with exponential functions, maybe that's a little more recent on your mind. If we had a plus 3 up here, you made your middle x a negative 3. So that is still going to happen. So what I'm going to do when I plug in my x's now, let's see, a little lower. Oh, sure, I'll plug in negative 4. But you know what else I'm going to plug in? I'm going to plug in negative, how about I plug in negative 3.5 and see what happens. So a little smaller than negative 3 and maybe negative 5. Ooh, all right. Now we have to plug it into maybe a little more of a complicated formula. It's going to be negative 4 over x plus 3. So it's negative 4 over x plus 3. That's my formula that I need to use. So it might be a little more difficult this time. I'm just going to erase my x, put in negative 5, and what's that going to be? That's going to be negative 4 over negative 2, so negative 2. So if we look, sure enough, we better have a point, negative 5 and negative 2. Negative 5 and negative 2. Let's see, where is that going to be? Negative 5 and positive 2, because your math teacher forgot to do a double negative. That was embarrassing. Negative 5, let's see, 2, 4, 5, and positive 2. There it is. There's that point. So again, you can see that it is fitting everything we want. So let's plug in that negative 3.5, negative 4, negative 3.5 plus 3. That's negative 4 over negative 0.5, negative 4 over negative 0.5 is going to give us 8. Positive 8. So if we look at our graph, sure enough, we'll see negative 3.5 and positive 8 as an answer. Let's find that one, shall we? Negative 3.5 will be about here. And what did we say? Positive 8, 2, 4, 6, 8. Oh, 3.5, Amy. 3.5 will be right. Let's see. Sorry, that's 3. This is 3.5. So we're looking at positive 8, 2, 4, 6, 8. There it is. So again, you can see these really nice shapes coming into form. And I just picked some above, some below, and some very close. So on the other side of negative 3, you should probably put in negative 2, maybe even negative 2.5, and see what those ones look like. And sure enough, I feel like you guys know how to plug in points, but just in case, maybe I should for you. I don't want to go ahead and assume anything. If you know how to plug in points, maybe you want to fast forward this part of the video. I will plug in negative 4, like I said I was going to. So let's see if I do that. I get That's going to be negative 4 over negative 1, which is positive 4, and sure enough, that should be a point. Let's see, my next one would be negative 4 over negative 3 plus 3, and you can see how that one's the no answer. Let's see, negative 4 over negative 2 plus 3. That's be negative 4 over 1, negative 4, and let's make sure that that looks like a point. Negative 2 and negative 4. Negative 2 and negative 4 is right here. That works. See, it's right there. And then if you did the 2.5, let's take a look. Negative 2.5 plus 3. That's negative 4 over positive 0.5, which is going to be negative 8. And if we went to negative 2.5, if you want to find it, because you will have to graph these on the homework, negative 2.5 and negative 8 surely is right there. You can see it. So your goal is to make sure the most important x is your middle x, and then you surround it with numbers that are very close to it so you can see what the shape is going to look like. The last one we're going to do, we have a couple more transformations to look at. The negative is going to reflect it. The 4 is going to be a vertical stretch of 4. Did I do those on the last one? Well, I'll find out after I do this. The minus 5 is going to be to the right 5 units. And what else? I have this plus 2 in the back. That's going to move it up 2. So the right 5 is going to change our asymptotes, and the up 2 is going to change our asymptotes. So let's see how they change them. All right, so the vertical asymptote is the vertical line that it will approach but never touch, and it is the x value. So you see how we have x minus 5 right there? If you're not sure how to do it, I will show you mathematically. You say x minus 5 equals 0, and then you add 5. So your asymptote is x equals 5. And if you look at our graph, sure enough, here, let's find x equals 5. We'll draw it with a broken black line. Let's see, 2, 4, 5. You can see there's the bottom half of the asymptote. There's the top half of the asymptote, and that's at x equals 5. Because remember, we can't have a denominator of 0. And this time, guys, I did give you a horizontal asymptote that's not 0. It is the horizontal line that it approaches and never touches. Usually, it's at 0. But because of this, it's a big 2 in the back. We keep this as a positive 2. Unlike the x's, you don't change its value. And if we look over here, let's look at where y is 2. Let's get my broken line. Here's where y is 2. Draw a nice line there. Draw a nice line there. And you can see that, again, the red one is the parent function from the very beginning. And the black one has been, you can see it's got moved to the right. It got moved up. It got reflected. And it is vertically stretched by a factor of 4. Your domain, let's talk about that domain again. Remember, it's all real numbers. Your little heart, you can plug in anything you want to for x except... what was r in the denominator? A minus 5? X is not allowed to be positive 5 because that would give you 0 in the denominator. Now your range is also real numbers, except, now unlike the other problems, y, let's see, you see that back number? That back number is your asymptote. By definition, an asymptote is something you can't get, so you put the back number right here. And so it's all real numbers except for y equals 2 because you approach it. So you might say, well, Miss Angela, what x's would I pick on this one? Well, your middle x would be right here. So you would pick a positive 5, and that one would give you a no answer. And I would highly encourage you to plug in probably 4.5, probably 4, and maybe 3. See how that behaves. And then I would encourage you to plug in 5.5, like 6 and 7, and see how it behaves there. And you would get that nice black shape over there. Again, remember to put some arrowheads on them. I simply copied them from Desmos, which does not include the arrowheads. And I would let you go ahead and plug that in on yourself. You know what? I will plug in 6 for you just in case you're like, boy, I don't remember how to plug stuff in. So our equation is, I'm going to write it big so I can just shrink it down. It's negative 4, maybe I'll fit it, over x minus 5 plus 2. And I wanted to show you how to plug in 6, right? So I take out x, put in 6. So let's see, that's going to be negative 4. Shrink this down. So that's going to be I'm going to write nice and small for you so we can fit it on here. Be negative 4 over 1 and then plus 2, which would be negative 4 plus 2, which would be negative 2 when you get it all in there. Now you could use your y equals on your calculator. And if we go to positive 6 and negative 2, we should see a point. 2, 4, let's see, 2, 4, 6. And what do we get? Negative 2. 2, 4, 6, negative 2 is a point. So you can see the main things you need to do. Step 1, find your asymptotes. Find and draw your asymptotes. Very big deal. Find and draw your asymptotes. Step 2, pick good x's. And how many did I pick? Let's make a general rule that you need to find 3 above and 3 below your no solution. I'll say the middle number. That way you have nice points to show me. And then you plot them and connect with arrows. I'll say plot, connect, and make sure you get some arrowheads on them. Remember, they have to approach your asymptotes but not touch them.